All right, good morning, guys. Today we're going to be covering 10.4 volumes of prisms and cylinder notes. Our learning target is I can find the volume of prisms and cylinders and composite shapes. Now, we've been covering surface area for the first half of Unit 10. For the latter half of Unit 10, we're going to be just covering volume. And volume is going to be a little bit easier because we don't need to be thinking about is anything being covered or any of our bases being covered by another shape or anything like that like we would have to worry about with surface area. The main thing with volume is just to make sure that you know the formulas and you know the concepts behind them. So let's go ahead and get started with rectangular prisms. First off, what is volume? Well, similar to area is just the space a 2D object takes up. Volume is the space that a three-dimensional object takes up. So if I'm adding a new dimension, volume is equivalent to the area of that dimension. So volume is just the amount of space a three-dimensional object will take up. Now, for a rectangular prism, our formula for volume will just be length times width times height. And with that formula, it doesn't matter which side you choose as length, width, or height, because we're multiplying all three values. And if I'm multiplying all three values, it won't matter the order that I multiply in, because I'll get the same answer regardless. For example, with this rectangular prism here, I can do 4 times 2 times 6, and that will get me 48. Or I can do 4 times 6, which is 24, times 2, which is also 48. But regardless, the order doesn't matter in which you multiply, because no matter what, you would still get the volume of 48 units cubed. So just keep that in mind. With rectangular prisms specifically, it doesn't matter the order in which you multiply. Now, you may also notice here that our units are cubed. They're raised to the third power. And that goes back to it being the amount of space that a three-dimensional object takes up. Since I'm in 3D, it's going to be to the third power. Much like when we were in 2D, it was units to the second power, or units squared. So now that we're in 3 dimensions, we're dealing with three-dimensional figures in three-dimensional space, it's going to be units cubed. Lastly, just make sure that you have the formula written down for the volume of a rectangular box as length times width times height. All right, let's go ahead and try out some examples. So we want to find the volume of the following rectangular prisms. Now this is the most common type that you'll see in this class, where you can see through the prism itself and you can see that everything's intersecting at 90-degree angles, making this a right rectangular prism, because again, it intersects the base at 90 degrees. Now, if I want to find the volume here, I just do 20 times 5 times 15. 20 times 5 will give me 100. 100 times 15 will give me 1,500. So our answer is 1,500 units cubed. For our second problem, we want to find the volume of a rectangular box with dimensions of 2 inches by 3 inches by 5 inches. Now, keep in mind, this is more than likely what you would see in the real world. If you were to go to like a hardware shop and you were buying some supplies, they'd sell you a 2x4. So that's typically how they're going to write those out for you guys. So just keep that in mind as you're looking through, but this is going to be the most realistic in terms of you're going to be seeing that in the real world if you choose to go out into construction or construct anything yourself for like a hobby or a project or something. Regardless, this method still applies. We're just doing length times width times height, and it doesn't matter which one you choose as which. So it's just going to be 2 times 3 times 5. 2 times 3, of course, is 6. 6 times 5 is 30. And our last one. You won't see this one as common where you can't see the actual back of the prism, but you will see these here and there. And again, same thing applies. Just do 9 times 10 times 8. 9 times 8 is 72. 72 times 10 is 720 units cubed. All right. So those are our first 3 examples. Pretty straightforward. And again, prisms shouldn't be very difficult with this. Just keep in mind we're taking the base, the area of our base, and we're stacking it up however many times as we need to get to that height. That's all we're doing. We're taking a very small area and we just keep stacking those areas until we reach our height. So, if I have other prisms, meaning a triangular prism, a hexagonal prism, or even a composite figure made up of two rectangular prisms, we would use the formula big B times H, where big B is the area of our base and H is the height of our prism. Again, big B is the area of the base. So I need to find the area of whichever shape I'm dealing with. So for instance, if I have a triangular prism, for big B, I would use the formula 1/2 base times height, because that's the area of a triangle. If I had a regular pentagonal prism, I'd use the formula for big B as 1/2 the apothem times the perimeter to get that big B, to get that area of the base. And if I had a composite figure, well, I just find the area of each rectangle and then add them together. So keep that in mind, big B will change based upon what shape we're dealing with. And that all depends on the base. So big B will always stand for the base. Now, if I have a figure that's leaning to the side, and we can see that occurring right here, it's kind of leaning off to the side, we call those oblique prisms. So again, oblique prisms are leaning to the side. Meanwhile, right prisms have the height and the base intersecting at 90 degrees. And the height and the base should always be perpendicular to each other. If it is oblique, well, my height's going to be outside of my prism because it still needs to intersect the base at 90 degrees, no matter what. And if you run into something like this, there's quite a few different methods that you can do to find that height. If you have one of the values, or two of the values even, you can use Pythagorean's theorem. If you have one value in an angle measure, you can use SOHCAHTOA. There's lots of different ways for you to solve for that height. But just keep in mind that height will always be perpendicular to our base. Lastly, let's go ahead and try and find the area of the shaded face of the right pentagonal prism. They tell us that that area of this face is 51. We want to find the prism's volume. Now again, volume is equal to big base times the height. So if they're telling me that the area of the pentagon here is 51, that means that big B is 51. And looking at our prism has a height of 7. So therefore, our volume will be 51 times 7. 51 times 7 will leave us to 357 units cubed. Now, before I move on, I just want to talk about one last thing with oblique prisms and oblique cylinders. It goes for anything that's oblique compared to right. If I have an oblique prism or cylinder that has the same base and height as a right prism or cylinder, then their volumes will be the same. And the reason for that is something called Cavalier's principle. In fact, if we look at these stacks of quarters here, we can see that one is a right cylinder and one is bended at kind of an angle. It looks kind of bent in the middle. And the main thing that I really want to focus in on here is that both of these stacks take up the same amount of space still. Regardless of if one is hit in the middle and kind of bent sideways, they still take up the same amount of space. And so regardless of whether my prisms are oblique or they are right, as long as their bases are the same and their heights are the same, they can be at any angle. They'll still have the same exact volume. So that's a very important concept to know, that oblique prisms and cylinders, oblique figures, will have the same exact volume as right prisms, cylinders, or figures, as long as they have the same base and height. So just want to make sure that that's clear, and we'll probably see some examples of that down the road as well. All right, next up, let's go ahead and find the volume of this triangular prism. Now, since this is a triangular prism, that means that our bases are triangles. So we need to actually find the area of a triangle. Now we know that the area of a triangle is just 1/2 base times height. And again, that's the height of the actual triangle, not the height of the prism. So we're not going to use this 15 for H here. We need the height of our triangle for that. And if I look at my triangle, I notice that we have an isosceles triangle. So I'm going to go ahead and draw this out in 2 dimensions and show my height within it. And I want to find this height. Now, this base gets split perfectly in half because I know that the altitude of an isosceles triangle will split it into 2 congruent triangles, making each side 6 and 6. From here, I can use Pythagorean's theorem to solve for our missing side length, h, and that will give me 6 squared plus h squared equals 10 squared. And you may look at this and be like, oh, that's a 6, 8, 10 triangle, so our height is 8. And you're absolutely correct. Of course, if you need to use Pythagorean's theorem, you definitely can. 6 squared is 36, 10 squared is 100. 36 minus 100 is 64. The square root of 64 is 8. This 8 is what I'm going to use for the height of my triangle. And again, the height and the bases need to be perpendicular, so therefore my base of the triangle, little b, is 12. So therefore the area of my triangle is 1/2 times 12 times 8. Half of 12 is 6. 6 times 8 is 48 units squared. With this 48 units squared, with this base, I'm going to keep stacking up these bases together until I get to a height of 15. So therefore, my volume will equal big B times H, or 48 times 15. If you enter in 48 times 15 onto your calculator, you'll get your final answer of 720 units cubed. And that's it. So again, keep in mind, the base matters for this in regards to which shape it is. Once you find the big base, then you just need to multiply it by the height. But don't forget, you need to know the area of that base. Next up, we have cylinders. So the volume of a cylinder is very similar to the volume of a prism. It's still going to be big B times H. The main difference here, though, is that big B is now a circle. So big B is going to change into pi r squared. So therefore, the volume of a cylinder is pi r squared times H. Again, that's just the same thing as big B times H. Again, we have an oblique cylinder and a right cylinder right next to each other. And if these if these bases are the same and these heights are the same, do they have the same volume? Well, yeah, of course. Like we just talked about with Cavalier's principle, these two have the same exact volume if their heights and their bases are congruent. So, please don't forget, make sure that you have this in your notes somewhere. It doesn't need to be right here if you put it earlier. But make sure that you know that the base and the height are always perpendicular. We can see that right here. All right, let's go ahead and try out an example with cylinders. We want to find the volume of the cylinder. In looking at this, we see that we have a radius of 5 and a height of 12. So plugging that into our our volume formula, volume is equal to pi r squared times h. Well, r is 5 and h is 12. That will give me 25 pi times 12. 25 times 12 will give me 300 times pi is 300 pi units cubed. All right, our last and final problem. We want to find the volume of cement needed to form the concrete pedestal shown. Now again, we have a composite figure here. But with composite figures, it's different from surface area. We only have 2 steps. We need to find the volume of one of these, then find the volume of the other, and then add them together. I guess that's 3 steps. But again, just find the volume of each shape, add them together, and that's your answer. Because again, volume is how much space something takes up. So regardless, I don't need to worry about if something's covered. I'm just worried about the amount of space they're taking up. So we'll go ahead and we'll start with our cylinder here. Now I made a mistake and I called it a cone within the notes, but this is a cylinder. So ignore this. You can write cylinder here if you would like. We know that the formula for that is big B times H, and since big B is a circle, we'll use pi r squared in place of big B. Of course, looking at this, we see that our radius is 1, and the height of our cylinder is 5. 1 squared is 1. 1 times pi is pi, Pi times 5 is 5 pi. So the volume of the cylinder is 5 pi meters cubed. As for our prism, well, we would just do length times width times height. And again, the order doesn't matter for those. So it'll just be 4 times 3 times 1/2. Well, 4 times 3 is 12, times 1/2 is 6. So the volume of our prism is 6 meters cubed. The last thing that we need to do is just add our two volumes together. 6 meters cubed plus 5 pi meters cubed will leave us with 21.7 meters cubed. That's our final answer. All right, guys, thank you so much for watching today. If you have any questions, please let me know. But